In this video, I'm going over the Chapter 7 test review. So it wants me to draw the given angle, rewrite it in degrees and radians, and then state the reference angle, name a positive and coterminal angle. So negative 300, this one I work backwards on the circles. This is negative 90, negative 180, negative 270, negative 360. So this one should be right here. And when I draw my arrow to show the direction it went in, it goes clockwise. To turn this into radians, I want to do negative 300 times pi over 180. So when I go to type this in my calculator, I want to do negative 300 divided by 180. I ignore the pi for now. And then I go math, fraction, enter. So that gives me negative 5/3. And then I add the pi back in when I have my answer. This means I want to find my reference angle. So if I look at this line I just drew, my reference angle is measuring my distance from here to here. This is going to be 60 degrees because I can just add 360 to that. A coterminal angle that is positive, I want to add negative 300 to 360. It's going to get me just positive 60. And then a negative coterminal angle, I'm going to do negative 300 minus 360, which gets me negative 660. On number 2, this one is 395, so this one is positive, so I'm going to count like this. It's more than 360, it's going to end up over here. When I draw this out, I want to show that it goes around a complete sign and then ends up back there. To convert this to radians, I'm going to do my work up here. I have 395 times 1 pi over 180. So on my calculator, I'm going to do 395 divided by 180. And I go math, fraction, enter. So I get 79 over 36, and then I'm going to put back in my pi. My reference angle is the distance from here to here. So I'm going to take 395 and subtract 360, which gets me 35 degrees from my reference angle. And I'm only using 360 in these two because they both ended up in the first quadrant. So my positive coterminal angle, I can use my reference angle because it is the first quadrant. It's going to be 35 degrees. Then my negative coterminal angle, so I already subtracted 360 to get the 35, so I can subtract 360 again. 35 minus 360 gets me negative 325. Over here, I am in radians, so this is negative pi halves, negative pi, 3 pi halves, and negative 2 pi. 3 pi fourths is a little more than pi halves, so that is going to be over here. And it went the opposite direction, so it goes like that. To convert this to degrees, I want to do negative 3 pi fourths times 180 over pi. My pi's will cancel out, so then I'm just doing negative 3/4 times 180. Let me move this out of the light. This gets me negative 135 degrees. My reference angle, so I want to see how far this is from here to here. You always measure your reference angle from the x-axis. I am going to do pi minus 3 pi fourths. So I can really type that in my calculator as 1 minus 3/4, which gives me 1/4. So writing on my paper, putting back in that pi as pi fourths. A coterminal angle, this one I want to add full circle, so 2 pi plus negative 3 pi fourths. So really on my calculator I can do 2 minus 3/4. Turn that back into a fraction, is 5 pi fourths. For my negative coterminal angle, I'm going to do negative 3 pi fourths minus 2 pi. So negative 3/4 minus 2, turn that back into a fraction, is negative 11/4 pi. Same idea on number 4. This one's positive, so this is going to be pi halves, pi, 3 pi halves, 2 pi. 13 pi fifths I'm actually going to turn this one into degrees before I go ahead and graph it so that I can see where this is. So I'm going to write this up here, 13 pi fifths times 180 over pi. So my pi's cancel out. I have 13 fifths times 180 gets me 468 degrees. So because that's more than 360, I want to subtract the 360. 108, so if I think back, this is 90, 180, so that's going to be right there. I'm also going to write this as, oops, not 90, 108. I'm going to write this as 108, so I know what that was. To find my reference angle, I'm just finishing off to the x-axis. I'm going to finish finding this in degrees, so I'm going to do 180 minus 108, which gives me 72. And then I want to turn that back into radians. So I'm going to do 72 times pi over 180. I do 72 divided by 180. Math, fraction, I have 2/5, and then I add back in my pi. So my reference angle is 2 pi fifths. To find a coterminal angle, I want to do 13 pi fifths plus 2 pi. So 13 fifths plus 2, turn it back into a fraction, is 23 fifths pi. A negative coterminal, I'm going to do 13 pi fifths minus 2 pi, which still gives me a positive value. It gives me 3 pi fifths. So I want to go ahead and subtract this again, which gives me negative 7 pi fifths. Okay, this one wants me to find the length of the arc subtended by an angle measuring 7 pi 6 if the circle's radius is 5 meters. So for here, I want to use the S equals R theta formula. This is my theta, this is my radius. My angle should always be in radians, which this one is. So I just plug into the formula. I have S equals 5 times 7 pi 6. Then I just want to go ahead and type this into my calculator. Which gets me, it doesn't tell me what around I'm going to do to the hundredths place. So I'm going to do 18.33. Number 3 wants me to find the area of the sector. So the area of the sector is A equals 1/2 hold on, let me look at the formula really quick. R squared times theta. Where my theta should again be in radians. So I want to first turn this into radians. So I'm going to do 60 times pi over 180, which gets me pi thirds. So plugging into my formula, I have A equals 1/2. My radius is 10 times pi thirds. So 1/2 times 10 times, oops, 10 squared. So this is going to get me 78.54 inches squared. I should have had my units on the last one, that was meters. Okay. Number 4 says the point P is located at the intersection of the unit circle and a terminal side of an angle theta in standard position. Find the coordinates of P. This one isn't on the test, so skip it. This one wants me, it tells me theta is an acute right triangle. Evaluate for the other 5 functions of theta. So remember SOHCAHTOA. So it gives me secant, so this is the inverse of cosine, so this is hypotenuse over adjacent. So if I draw my triangle, this is my opposite, this is my adjacent, this is my hypotenuse. So I want to fill those in. I have 13 and 12. I need to use the Pythagorean theorem. So a squared plus b squared equals c squared to find the missing side length. This is my c. I'll use this as a, and then I need to find my b. So I have 12 squared plus b squared equals 13 squared. 12 squared is 144. 13 squared is 169. Subtract 144 on both sides. I get b squared equals 25. Square root, b is 5. So, filling in the rest of these values, secant is the reciprocal of cosine, so I can write that as 12 over 13. Then sine is opposite over hypotenuse, so 5 over 13. Tangent is opposite over adjacent, so 5 over 12. And then I want to flip for my reciprocals, so cosecant is the inverse of sine, so it's 13 over 5. Cotangent is the reciprocal of tangent, that's going to be 12 over 5. Okay. Number 6 says in a right triangle, sine equals negative 7 over 25, and it's in between pi and 3 pi halves. So remember, this goes pi halves, pi, 3 pi halves. So this is telling me my picture is here. My reference angle is always connected to the origin, so my opposite is negative 7. My hypotenuse is 25. I need to find that missing side length, so I'm going to have negative 7 squared plus b squared equals 25 squared. Negative 7 squared is 49. 25 squared is not a number I know off the top of my head. That is 625. So then I want to subtract 49 on both sides. We get b squared equals 576. And I want to go ahead and take the square root of that, which gets me 24. So cosine, oh, let me label these. This was opposite, this is my hypotenuse, and this is my adjacent. Cosine is adjacent over hypotenuse, so 24 over 25, but because I'm in the third quadrant, this 24 should actually be negative. And then tangent is opposite over adjacent, so negative 7 over negative 24. Because of the double negatives, this is going to turn it into positive 7 over 24. This one wants me to use the unit circle to evaluate the following. So sine when it's negative 60. So negative 60 is in the fourth quadrant. If I remember, actually, I have this table on number 13 that I'm going to fill out really quickly, and then I'm going to go back. So for this, it's like the table we wrote earlier, it's just sideways. So my values go 1 over 2, square root of 2 over 2, square root of 3 over 2. Cosine goes backwards, so it's square root of 3 over 2, square root of 2 over 2, 1/2. Tangent takes sine and divides by cosine, so this one is square root of 3 over 3, because that's really doing 1/2 divided by square root of 3 over 2, which I could rewrite as 1/2 times 2 over square root of 3, which simplifies to 1 over square root of 3, and then I would want to rationalize my denominator, which gets me square root of 3 over 3. 45, anything divided by itself is 1, and then on the second one, or 61, I have square root of 3 over 2 divided by 1/2. So again, if I wrote this out, it'd be like that. I can flip the second fraction and multiply. The 2's cancel out, which is square root of 3 over 1, which simplifies to square root of 3. So anyways, I was trying to find the sine of 60, which is going to be the square root of 3 over 2. But because I'm in the fourth quadrant, my sign is going to be negative here, because remember we have all students take classes. So everything is positive in the first quadrant, only sine is positive in the second, only tangent is positive in the third, and only cosine is positive in the fourth. So since this isn't cosine, it's negative. Tangent when it equals 5 pi 6, so that is over here. My reference angle is just going to be pi 6, which remember is 30 degrees. So if I go back to that chart on the other page, tangent of 30 degrees is square root of 3 over 3. And because I'm in the second quadrant, only sign is positive there, so this one should also be negative. Part C is secant when it's 315. So 315 is in this quadrant. My reference angle is going to be 45 degrees, because I take 360 and minus the 315. So this is secant, so its reciprocal function goes with cosine. Cosine of 45 is square root of 2 over 2. So I want to flip that to turn into secant. It is going to be 2 over the square root of 2. I want to rationalize that. Sorry, that's off the screen. So square root of 2 over square root of 2, which gives me 2 square root of 2 over 2. The 2's cancel out. It's just the square root of 2. And then because I'm in the fourth quadrant, I need to see if cosine is positive here, which it is. So my answer is just square root of 2. Number 8 says a cable is attached to the top of a pole and mounted on the ground 3 feet from the base of the pole. So it's tied here and here, so 3 feet from the ground. The angle of elevation, so looking up, is 78 degrees. What is the height of the pole? So how tall is it? This one I have my opposite and my adjacent, so this is going to be tangent. I have tangent 78 equals x over 3. I want to solve for x, multiply both sides by 3. I get 3 tangent 78 equals x. I want to solve this on my calculator. If I'm on a newer calculator, it will tell me if I'm in degrees at the top. If not, or if I'm in radians, I want to go second mode. Just kidding, regular mode. And then I want to arrow down to where it says radian in degree, and I want to highlight degree if it's not black already. I press enter. Then I press second mode to go back home. And now I want to type in my trig function, which is 3 tangent 78, which gets me 14.11. And this was feet. Let's not write my thoughts on that. Okay. Number 9 says a parasailer is attached to a boat. With a rope 56 feet long. Find the angle of depression. So, angle of depression. I drew the triangle the wrong way. Let me draw this again. Boat. Guy. Angle of depression is in the top corner with the rectangle looking, or with the triangle looking down. Is 19 degrees. Find the height above the water. So, this part right here. That is my opposite and hypotenuse. So this is going to be sine 19 equals x over 56. Multiply both sides by 56. Which gets me 18.23 feet. Okay, this one wants me to solve the triangle. So if I want to find E, this is an angle, I'm going to do 180 minus 59 minus 90, because I know 2 of my angles on the triangle, and triangles add up to 180. So that gets me 31 degrees. Then to find D, this is my opposite. I know my hypotenuse, so I'm going to do sine of 59 equals D over 17. Then I want to multiply both sides by 17. So I have 17 sine 59 equals D. Which gets me 14.57. E is my adjacent, so I'm going to do cosine 59 adjacent over hypotenuse. And then to solve for E, I have 17 cosine 59. This is going to get me 8.76. Okay, this one wants the coordinates of this intersecting the unit circle. So remember, it goes negative 90, negative 180, negative 270, negative 360. So if I'm intersecting the unit circle, I'm right here. My coordinate points there are just 0, 1. That's all it wants here. Okay, one more rows. Hopefully it'll, there you go. This one wants me to graph the following functions, identify their amplitude, horizontal shift, period, length, and vertical shift. So amplitude is my number out front. This one is a 1. My period is if there's something in front of my x, I take it and divide by 2 pi. If there's nothing in front of my x, it's default 2 pi. Horizontal shift is the same thing as my phase shift. So if this is something added or subtracted inside my parentheses, there's nothing. My vertical shift is 2 up. So that is going to change my midline. So I'm going to go up to 2. Draw my midline. This one's sine, so I start at 0. Because it's a period of 2 pi, everything is going to be counting by pi halves. So my amplitude is 1, so I go up 1 from my midline. I go back to my midline, I go down 1, and I go back to my midline, because sine always starts at 0. On B, I have an amplitude of 2. My period is still 2 pi, because there's no numbers in front of my x. My horizontal shift is pi right, opposite the sign, and my vertical shift is none. So I'm going to be on my midline, but instead of starting at 0, I'm going to start at pi. So I'm going to draw a dashed line to show me that I'm starting here instead. So cosine normally starts with my amplitude plus my midline. So I'm going to start at 2. Then it goes to my midline, goes down below my midline, counting by the amplitude, back to my midline, back to my midline plus my amplitude. And then I just want to go ahead and connect my dots. On C, this one, you want the positive value for your amplitude, so it's just 3. My period is 2 pi because there's nothing in front of that x. My horizontal shift is pi halves left, opposite the sign. And my vertical shift is 1 up. So I'm going to start by drawing my vertical shift. This is my midline. And then I also went pi halves left, so I'm going to draw a dashed line there to indicate I want to start there. This is sine, so it's going to start where those two lines are crossing, but I have this negative, so that means I want to reflect my graph. So instead of going up 3 from that point, I'm going to go down 3. I'm going to go back to my midline. I go up 3, back to my midline. And then just like that.